Hello, today we're going to look something that known as stoichiometry, and this calculation that are based on the mole concept and the Browns-Lee chemical equations. By definitions, we can say that stoichiometry is the relationship between the relative quantity of the substance taking part in the chemical reactions and the product formed. And in this case, the things that we're looking at is about the relationship that is shown by balancing the chemical equations. So it means that we can look at an example from this mole concept on how we can compare the number of moles that is based on this question. That our question here is said that calculate the volume of carbon dioxide gas that will be produced at STP when 10 grams of calcium carbonate is completely decomposed by heating as shown by the following question. So we have given the equation here, that is calcium carbonate that is salt when it is decomposed. When it is decomposed here, we come to get the product that is calcium oxide, that is salt, and the carbon dioxide. So it means from that our question is basically to find the volume of carbon dioxide that will be released by this equation. So it means that we have the calcium carbonate, that is salt. This one, when decomposed, it produces calcium oxide, that is salt, and the carbon dioxide, that is gas. So through these chemical equations that is already balanced, we look that we have given the data here. Mass, the mass was 10 grams. Again, in part of number of mole in stoichiometric coefficient between calcium and the carbon dioxide is 1. So it means that the ratio that we have, so the ratio or stoichiometric coefficients between calcium carbonate ratio carbon dioxide is 1:1. So these are number of moles that will be correlated until the end we get the answer. But in part of carbon dioxide here, we have asked about to find the volume at STP. So this is the major categories that we're going to follow with it. So from that, the things that we're going to look further is about to find the number of moles of calcium carbonate, and after that we come to correlate between the calcium carbonate and the carbon dioxide. As you see here, this calcium carbonate have a mass of 10 grams, but in terms of molar mass, this is mass. But in terms of molar mass here, we can have a molar mass of calcium is 40 plus. The molar mass of carbon dioxide is 12 plus. The molar mass of oxygen is 16, but there are 3 oxygen, so we times 3. So into brackets, as the SI unit is gram per moles. So it means that the molar mass now it will be equal to 100 gram per moles. So the purpose of doing so is to come up to this formula, that is number of moles is equal to mass over molar mass. Molar mass, that is gram, and this one is gram per mole. So from this perspective, what I think we're going to look now is about the number of moles of calcium dioxide that was used to yield 1 mole into stoichiometric coefficient or from Browns-Lee chemical equation in order to find the volume at the STP. So from that we will look that number of mole is equal to, so we take a mass that is 10 grams, we divide by the molar mass, that is 100 gram per mole. So it means that our answer here, it will be, when we plug it on the calculator, we take 10 divided by 100. The answer, it will be 0.1. So this one gram, it will cancel with this gram. So this one will cancel with this one. So at the end, it will remain moles. So the SI unit is moles. So it means that therefore this calcium carbonate, before decomposing, it was 0.1 moles. It means that for 10 kilogram. So after that, if you obtain about that aspect, now we go on to the balanced chemical equation. It means that our equation here is calcium carbonate. Here, calcium carbonate, when it is decomposed, you form the calcium oxide and the carbon dioxide. So the things now that we're going to look is about the stoichiometric coefficient. That is, here is 1 mole and here again is 1 mole. So from that, now we're going to correlate about that 1 mole from the balanced chemical equation of calcium carbonate is equivalent to 1 mole of carbon dioxide at balanced chemical equation. Therefore, from the calculation of 10 grams of calcium carbonate, and that is 0.1 moles, it will be equivalent to how many moles of carbon dioxide? So at the end, we're going to cross multiplications. That it will be the moles of carbon dioxide moles. It will be equal to 0.1 times 1 divided by 1. This one is moles, this one is moles, and this one is moles. So up to the end, this one will be cancelled out. So our question here, it means that this carbon dioxide also, it will be have moles of 0.1 moles. So from that, we come back on the formula that at STP, any gas, any 1 mole of any gas, any 1 mole of any gas at STP is equivalent to or is equal to 22.4 decimeter cubic. So now we're going to look on these relations. That is, from our value that we obtain, it will be that is 1 mole of carbon dioxide at STP is equivalent now or is equal to 22.4 decimeter cubic. Therefore, if 0.1 moles of carbon dioxide formed moles, it will be how many volume? Or so from that we're going to cross multiplication. So at the end, it will be 0.1 mole times 22.4 decimeter cubic divided by 1 mole. So this moles will cancel with this moles. So at the end, we're going to this volume of carbon dioxide at STP. You see. So from that, it will be 0.1 from the calculator, and then we multiply by 22.4. That is the answer. It will be the volume of carbon dioxide at STP is equal to 2.24 decimeter cubic. So from that, now we're going to conclude that the volume of carbon dioxide at STP produced is 2.24 decimeter cubic when 10 grams of calcium carbonate decomposed. decomposed. So this one is the answer. Thank you.